We have three sets of results here. Set 1 here, and this is set 2, and that's set 3. In the first set, we've got 60, 60, 60, that is like exam results. So 5 sets of 60, the mean will be equal to 60. That's easy enough. You can add them up and divide them by 5, and that's how you find the mean, or x bar. In this case, they're all the same marks. In the second case, we have 5 exam results, 5 sets of results, and if you add them up and divide them by the number of results, you're going to get 300 divided by 5, which is 60. So that is basically the same mean. We've got 2 points which are deviating from the mean by this point here by plus 10, that is by plus 10, and here by minus 10. So we've got some scatter, we've got some deviation. So plus 10 minus 10, that will bring the mean of all the values to 60. Here, if we go to set number 3, you're going to have quite a number of points deviating from the mean, from the mean value 60. So I've got the first point here deviating by plus 10, this one here by plus 20, and here I've got a deviation of minus here minus 5, this one here, and this is minus 15, and that's minus 10. When you add them up, the total divided by the number of points is going to give you the same mean as 60. But we have some kind of scatter around the mean. If you like, this point here is deviating by minus 5 from the mean, and this point here is deviating plus 20 from the mean, this point here plus 10, and so on. I hope you can see these 3 results are similar. They have similar or the same mean, but they do differ in terms of scattering. So the first set here doesn't have any scattering from the mean. The second set here, we've got some scattering here, and the third set, it has much more scattering. What we like to do in statistics is to have some kind of measurement to this scattering. This is called standard deviation. Standard deviation, and the symbol for that is given by this sigma here. The sigma refers to the standard deviation. And the way to measure it, to measure the standard deviation, is to add all the scattering and then divide it by however many observations. So in this case we have no scattering, so the 0 divided by the number of points will give you 0 standard deviation. In this case here, that will also give us a 0. So really this is not very helpful. If we add all the deviation from the mean, that will give us a total of 0. So what we do, we have to square the difference and divide it by the number of points, as you will see now. So the formula will look something like this, and that is the observation or the mark, and that is the mean. So in the first case, the mean is equal to 60, and each point is equal to 60. So that's gonna give us a result of standard deviation of 0. And it's obvious there are no deviation of the mean. Now if we go to the second set of results, we'll find that there are this point here, at this point here we have no deviation. This point here we've got plus 10, and this is minus 10, and this is 0, and this is 0. If we worked out, we should finish with something like this. So it's going to be the deviation of this first point here, which is 0 squared, plus this point here, which is 10, plus this one here, minus 10, and you square that, and this one is 0 here and 0 here. We are adding the individual deviation from the 60. Then you divide by however many points. In this case we have 5 points, so we're going to get 200 divided by 5, and then all that under the square root, and that should give us this standard deviation of 6.324. Now in the third case, we should have a more scatter. You can see from the graph here, from the sketch, that we should have, so this value here, it should be bigger because we have more scatter. Let's work it out and see. So you can see the standard deviation here is much bigger than the previous one, and this is a measure of scattered. So this is a handy measure. Using this formula here, it can give us some kind of a feel of the scatter. We don't have to draw all these diagrams to have a feel of the scatter. Now there is another formula that we can use for the standard deviation, another formula which is equivalent to this, or it can be shown to be equal to this, and this formula is to add the sum of all the squares, the sum of all the squares of the observation, okay, sum of all the squares divided by the number of observation, then minus the square of the x bar or the mean, and then all that under the root. That should give us the same result. I will do the last set using this formula, and then you can see for yourself. So the first point 70, so 70 squared, plus the second point 80 squared, plus 55 squared, plus 45 squared, plus 50 squared, all divided by 5, and then take away the mean, which is 60 squared, under the root, and that will give you exactly the same value. So obviously you can see from this point, from this value, from this figure here, that the set result of the third set of result is it has more scattering than the mean, and that is a handy and a neat way to find that measure. This is the standard deviation.